Okay, so I'm just going to recap for the camera. So what we're looking at here is Bagpipes, which is a no-code tool to create your own cross-chain scenarios. Why is this a powerful thing? It's because it's really hard to do these cross-chain things, and even before you want to do them as a developer, it's maybe useful to kind of visualize them and see how they would execute and see what you can and cannot do. Remember, this is giving you everything you can do, but some of these chains, like if I wanted to send from Asset Hub to a parachain that doesn't have a channel with Asset Hub, for example, well, I wouldn't be able to do that cross-chain call. There is some complexities with the Polkadot world, right? Where like these chains, in order to be able to communicate with each other, they get it for free, but they actually need to open channels together. It's like Moonbeam, it has a bunch of channels with like I think Moonbeam is connected with all the parachains, a lot of them. Unique is connected to some. So anyways, but some chains aren't, right? So just so you know. So now what we're looking at is a cross-chain workflow where we said, okay, we're going to have Polkadot as the starting points. We have some dot here that we're going to send to the Asset Hub, which is it's a system chain, but it's really a parachain. And then the Asset Hub dot will then be sent to HydraDX, right? So just to exemplify this workflow. So now if I run this run workflow thing, check it out. It should, I don't have this address. I just need to finish this address here. So maybe we can do something funny and we can say like, so I'm sending from this social wallet account, and then from the Asset Hub, I'm going to receive it on a different wallet. Oh, maybe it's my wallet isn't connected. Okay, well that's fine. It's just gonna do something like, it's probably not something that makes much sense, but it's to showcase this, right? Okay, so if I run this workflow, incomplete data and some actions. What am I missing here, guys? No, this is just the bug right now in their UI that. Okay. So it actually works. So check this out at the top here. We've got Polkadot to Asset Hub to HydraDX, right? With the guys here that are the guys that are trying to build this, what they're trying to do is add like better and more intuitive UX. Like, yes, if you've been like thinking about parachains and runtimes and stuff for like months and months, the abstractions just kind of make sense. But this is kind of nice, in my opinion, right? So what we're looking at here is reviewing the transactions. So this is, so the first transaction is a cross-chain transfer from DOT to Asset Hub, and then the second transaction is a cross-chain transfer from the Asset Hub to HydraDX. Again, guys, like imagine like we can just have this one button in our React app. That would be really cool. Yeah. So if I go approve all, then I sign this transaction, and I'm going to be sending this one dot like this. So this is the first transaction I'm signing. And yeah, note that like the problem that this is also solving is that oftentimes you can construct scenarios in theory, but that means that your user would need to go on some Asset Hub powered dApp that says you can sign on this platform that they're using, then go to the HydraDX platform and sign over there. Terrible UX, right? We need to do better. So this really can help do that, right? And I'm signing in one place. So now it says, okay, I'm ready to go. Let's broadcast it to start execution at the top here. Yeah. Yeah, we need some music here. Executing, okay. Transaction included in block, yeah. Yeah, literally it's doing cross-chain transfers. The transaction fees are negligible because it's using XCM, so it's not expensive, right? It's not bridging or anything. But it is, sending data across different state machines, right? So it's taking a little bit of time. Oh, final broadcast to chain. Okay, now we're going to Asset Hub, I think. Let's see. Maybe it's already at the end here. Okay, it's not done Asset Hub to HydraDX yet. Okay, We're waiting. Good thing we have the background music. Is anything going wrong here in the back? Uh-huh. Come on. It's doing something weird where it's actually just, it looks like it's halting. Why is it doing that? Because maybe I don't have any dot here. I don't have dot on my asset hub. But I'm waiting for it. I'm waiting for it. Let's see what happened to the transactions here. You know what? Yeah, just for the sake of the time, and I want to keep the attention here. That yeah, okay, I can go quickly. I'll check. I'll just go on Subscan to see what happened to my dot. Okay, I did a teleport acid 2 minutes ago, and so it should have arrived there. Okay, let's see if we can run it. Let's run it again. It really shouldn't do that. Let's try it again. Yeah. Come on. Oh, it did something glitchy where I think it just halted on Asset Hub. Oh, okay. Transaction included. Thank you. Go. Okay, it looks like there's something that's maybe not going through on the back end. Let's watch this video because really Ramsey put a lot of effort into preparing the exact thing that's like the most interesting thing, right? It's like not so much the UI stuff, but can I use this as an endpoint in my app? So let's check that out. Yeah, let's just check that out.
In this video, we're going to show you how to create a bagpipe that queries the blockchain, specifically the Polkadot chain, for a balance, and then feeds that balance to your app. So your front-end web app will query the bagpipe for a balance, and then the result of querying the bagpipe querying the blockchain will then be given back to the app.
Okay, so just before he continues, this is a really cool thing that you can do. Let's forget about the scenario. But where you can just, so this apps thing, you can actually create queries. Like for example, you have a common query that you keep wanting to do, and then so you can draw this and say, okay, I need to query this chain, Kusama, and this is the query that I need to do, et cetera, et cetera. He's going to demo that. And then you can actually have these as fixed points in your app, right? It could be very useful.
And how we're going to do that is by creating a bagpipe like this. And then also we have something we've made earlier, which is just this very simple mini web app, which is a page that has a place where you can add your address in and click a button to check your balance. When you click this button, it will send data to this webhook once it's live and listening.
Does that make sense?
It will be used and turned into pills, and we can then program our query chain node to check the balance. So we choose the palette.
So the webhook is then what you're tapping into from your React app.
Right now, we need to send data to this webhook. We actually need to create the webhook next. Let's call it React with Bagpipes. Right. We've got now a webhook endpoint. Here it is. Let me just make the screen a bit bigger. Let's start listening. That's how we act. So we need to activate this webhook by sending it some initial data. So what we first have to do is copy this link and just, so we have a front end app here. So this is a replit of a very simple website, as you can see here. we also have another replit of a very simple Node.js server, and they're both connected to each other via providing the front end URL into the config of the server, and then providing going to the config of the front end, and providing the server's URL, and also providing the endpoint of the webhook. So we have a new webhook.
Right. So he's configured the webhook.
But we still need to send data to it so that the output of this webhook variables appears. So now we're running the scenario. Let's just check.
Okay, he's running the scenario.
We need to drag that into the field. So it's just about see the field there. So I think it may or may not drop in. So it won't drop in, we have to.
So it basically really abstracts like all the little things, and you could, you know, the concept of pills. Like you can add a pill to your flow. That pill could be the result of this query, which is maybe some specific chain that I'm looking for, then is passed in to become the input parameter of another transaction that I want to make. So you can automate these things. It's kind of cool, right? So right now, yeah, he's doing he's querying an account. This is a pill. Yeah, so from that query, boom, and then you can just have that rendered in React app.
So it allows you really to create dynamic workflows. Without it, you just have to hard code everything. You wouldn't be able to produce anything near as useful or some level of complexity as you would with pills. And it's also very fun and simple to use as well. So let's just run this again so that we can populate pills so that the query chain node executes, produces output, and then creates a green notification so that it can produce some pills for downstream nodes.
Yeah. So yeah, we're doing the webhook. And the Bagpipes is basically it's seeing all of the metadata of the chain, right? So it knows everything. Like it knows all the pallets, all the storage, everything. So you could, the programmability of your endpoints is pretty flexible. Okay, let's just see the end result. Okay, so then he's got a response. Boom, and then you can use that in your. There you go. That's your free balance. Yeah. And then that's the balance that he passed in.
We will send data to this webhook, and then the data of this webhook will be fed into this query chain node, and it will find the address by the bill, and it will produce the output, which is a bunch of data, and within that data is the free balance. We are going to
yeah. I mean, I think you get the idea. I mean, how elegant is that, right? Like, just have it in your JavaScript code. That makes sense, Matthew? Yeah. Yeah, but you're warming up to it. Well, so like the TLDR is like it's really hard to do cross-chain stuff. All these chains like Sui, for example, or Stellar or whatever, they're isolated, and then their response to, but isn't the future of Web3 multi-chain is, yeah, we have bridges. That's good, right? But it's not as good as it can get. Yeah, please. What are your questions? Huh? Oh, we can ask real questions. This is time to be real.
Oh, this is for the record.
Okay.
Okay, so I really like the tool. I think that it's like fantastic to be able to build out really quickly. I mean, what you're doing there is good. Like all those calls baked into one would probably take one of my engineers like a day and a half kind of thing.
Yeah.
If depending on the complexity, but obviously this scales really well. Like the more complex, the faster it'll be to use this tool. But where this gets kind of dicey for me is not being able to own those calls afterwards. Like I would pay like a subscription model to make those calls, for me, and then update it like once a month or whatever. Mm-hmm. But if I have to hit that webhook every time, I'm not sure about the security associated with that. And then I could end up directing my users to hitting a webhook that does something totally different, and like drains their wallet. And anyways, you know what I'm getting at. So the question's complete.
So my thoughts on that is that the team at Bagpipes is probably thinking about how they want to offer their service. This is very fresh development. I mean, it's alpha, alpha, alpha. Literally, that website is alpha.bagpipes.io. But you know, they're thinking about how they want to offer the service. So I think one natural step is to say we can host our webhook on our server, but you could also, you know, specify your server and host it there, right? If that's something you want to do. Yeah. But I think that the problem is not so much that also, it's that for your end users, like if I'm using your app that's built by your engineers and you're using our service, whatever, well, if I'm the user of your app, I want to make sure that what I'm signing is correct. Yeah. So I think it's on you, no matter what, to give that guarantee to your users. And it's just by that extension, you know, if you choose to use Bagpipes' server where the calls are being constructed, maybe that part of your UX should actually tell your users, if you really want to verify, just go and check it out. Well, yeah, but you know what I mean? So what you're saying is like, it's, that was exactly my point. Yeah, it is up to me to guarantee it is, right? Exactly. So if I'm using a bagpipe like webhook that lives over here, and I have to get direct them to hit it, that's where I want ownership, is over the calls that are being made. So like, and how they're packaged. Yeah. So I mean, what they provide at the very least, right, is if I do. But like, this isn't really like a criticism of it. I'm just thinking about the way that I would need to use it if we were going to use it. This is awesome feedback, though, for the team. Yeah. I would rather have my engineers spend a day and a half building out this like complex set of queries that we still get to own, than not own that, you know. Okay, but I just want to show you that you construct the thing and then it'll tell you review all the transactions that you've constructed, right? So you could then take that into some cool UI that is, you know, solving the problem of no blind signing, which is a very common issue. You don't, you know, MetaMask does this better now, things like that. It says what you're signing. Yeah, exactly. So that call data you can give. You can, you know, have a tool to verify it, if anything. Yeah. Do you need your engineers to do it themselves every time? Well, this tool is avoiding that burden. I mean, in my experience, our users, some like for different protocols, they just approve that thing as if it's like the terms of service on Apple. You know? Right. It's like hit the end, you know, like just run through it. They don't use it like a checklist. They don't. I mean, we'd love it if they always used it like, okay, what am I signing? But like, just sometimes our laziness of like the approve, you know, we are lazy, right? Yeah. And I think it's like great point on the terms and service. I mean, Daniel here might have different opinions, but exactly. So this is security, big time, like. So do you think that's just always how it's gonna be? Or do you think that there's actually ways we can innovate and really put the accountability on the user, but always, yeah, keeping them in check on what they're doing without it being stressful and just to be like a pain for them? I don't know, what do you think? Like, the internet didn't exist like 25 years ago, 26 years ago. Yeah, I think we're gonna innovate. We have to, I think. And I think that the wrong approach is just to be like, oh, it's like a term and service, because that's obviously not even working in Web 2. We need a better way. I don't know. Yeah, I mean, so okay, so the Polkadot world has two sort of paradigms in terms of you know, on-chain custom state logic, let's say, smart contracts, or actual parachains like application-specific blockchains, and I will answer the parachain stuff because actually that's like every chain. So every chain in Polkadot currently is built with Rust. We use the Polkadot SDK, and we these are just modules that are Rust, and then there's this we use a codec that then goes that basically indexes all of the possible functions, and so each module has different functions, so it's indexed by the functions, and then each function has each module has different events that it can be emitted and stuff like that. So all of that is generated as the metadata of the blockchain. So if I can show you real quick what that looks like. And so yes, that is type safe. That is you know, literally generating the programmable entry points to your blockchain. So, okay, if I go to this block explorer, I can probably see it's going to be a UI that's just rendering all this information. So, okay, this is, so for example, okay, I've got, yeah. So I'm actually connected to the Polkadot relay chain here. Remember, we've got a world in which we've got the main relay chain is providing security to all of these other parachains, these application-specific blockchains that Polkadot connects and provides security for. Think, why are all the L2s using Ethereum as a settlement layer? Is because the whole argument there is that that's where all the cash is in terms of the security and stuff like that. But in the Polkadot world, we've got this paradigm of all these different chains. So you actually need to connect to them specifically, right? Like when we were showing Bagpipes, we're actually connecting to a specific chain to then go and define the scenario. But here, yeah, so we're just gonna look into Polkadot's runtime. Oh, I went back. Yeah, so the runtime, and so yeah, they're all just palettes. Like Babe is a palette that does it's the round robin slot mechanism that is used in consensus, and that's its own module. Let's look at some more user-friendly modules. Like I think the bounties would be good, or the treasury could be a good one. Let's look at something even simpler. Yeah, okay, bounties is nice. So bounties literally is how Polkadot gives the ability for anyone to submit a bounty that then could be funded by the treasury. Like actually this event got funded by an on-chain bounty that does events for the Polkadot ecosystem that was then voted on by the curators, blah, blah, blah. So it uses this module called bounties. I digress because you asked the question about metadata, but what I'm trying to show here is that literally this is generated and it's type safe, and you've got now, I'm in the modules, it's still small. So modules, and the functions are here, and the events are here, right? And they're all indexed. And you as a programmer, all you need to know is the index of each module. So literally every chain will have these things. So it will be indexed by the module that then has functions, and you just need to know where to tap in accordingly. Peter, can you answer that question?
So like the motivation behind this question, like what I'm talking about is I'm trying to contrast. Like I'm a Move developer. Most of the stuff I do is on Move, and one of the lessons of Move, one of the things Move does really well is that like everything is type checked, right? And EVM is totally possible. Like to an EVM, if you have a you need to pass the constructor arg, you need to pass the interface to some contract as a constructor arg when you deploy. But it's like totally possible to at runtime when you actually deploy, just put in a random contract address. Nothing actually gets. It gets type checked by Solidity, but when you actually go and interact with the chain and transactions, it doesn't get type checked in that kind of way. Yeah, and I'm just saying like the question earlier was like how do we reduce the potential for error, right? When you reduce the human thing out of the error, and the thing that Move is really good at, the thing that Rust is really good at, is just doing as much with the compiler to prevent the introduction of states, like of invalid states, right? Don't even allow you to represent states that are invalid, right? That's one of the most famous design principles that Rust abides by. So I guess that's just kind of like, and like how to increase security of Polkadot. I mean, I think that what I see in crypto is like an easy way to, maybe not easy because it's like hard to develop these tools, right? But like a really good way to improve security of things is just type check more and like do more with the compiler. I don't know if that's possible, but.
Yeah, so basically, I hope this answers your question, which is everything Polkadot is Rust. So that means everything that he was just showing there in terms of like those types, those indexes, all of those things, everything's type checked at compile time. Because just like Move is in Rust.
This was the PR that actually made that change. I just remembered how it happened. Yeah, so the metadata type info is now actually part of the metadata, where that makes it really easy to have tools like subxt that generate the interfaces at runtime for the chain that you want to connect to, right? No, sorry, at compile time, it will generate an interfaces that then will be type safe for whatever application you want to be using. SubXT is a Rust library to interact with nodes, so they actually really needed to use this tool. They really needed to have type info in the metadata to be able to do that.
Yeah.
But
and what's really cool about SubXT is you can actually, so you can point it to the RPC of your Polkadot chain, and you can do a very just binary blob if you wanted. But something I actually use is I'll export the interfaces as Rust code, and then I can actually go look at the Rust interfaces there, import it into my own code, and now I have a exact type and encoded, decoded perfectly to my substrate chain, my Polkadot chain. So then I can just use it all from Rust super quickly without,
And you generate that metadata by passing in the Genesis block, right? Or the chain, no, the chains. You generate that metadata by passing in a chain spec, I believe. So it's similar like a smart contract. You would generate the ABI by just saying this is the smart contract address. But here it's a blockchain, right? So you're actually is it the Genesis block or the chain?
So they actually made it
spec.
even better. You can literally just point to the RPC now. You don't need to find chain spec. Literally just.
Oh, that's dope.
I'm going to RPC1 of Dweller for Polkadot, and I now have all of that metadata to use in my Rust code.
Yeah, and that's how a tool like Bagpipes makes it so Bagpipes renders that for you. Look, if I go, I'm gonna delete this. If I go I want to create a query. I want to query Polkadot, and I want to check out the palette. I'll just go bigger here. Palette is a module. It's a Rust module that is doing the thing that is making that app chain customized in whatever way. But you have palettes that do bounties, that do asset management. We saw one that did bounties, so I'll check that out. If I go, so I'm going to do a query. But okay, what I'm trying to show here is that this app is all it's doing is it's using the metadata of this blockchain to be able to render all of this stuff. It's not hard coded, not So if I go bounties and then again it's a train query, selecting the palette, selecting the method, and all of this stuff is thanks to what we're just talking about, basically the type safety in how the metadata is generated, and it is reproducible. It is never going to fail. Yeah.
The other thing I think that the other lesson for Move. So I think you said earlier that Move is based on Rust, or the language. You don't exactly use Rust, and there is actually an important difference. It's not so much Rust; it's more that they took the type checker from Rust, and then now they're applying that to NFTs, basically. They have objects, which is conceptually an NFT. In Sui, you can't have state that just exists. It has to be, all state exists as an NFT. It has to have a certain owner, or it can be owned by everybody, right? There's different ownership mechanisms. And really what they adapted the borrow checker to do is to, it basically enforced the invariant that no object can be owned by two things at the same time, right? Mutable, they basically took that mutable versus immutable, reference checker, and it's if something is either immutable, it's owned by one person.
That's so interesting. Wait, so you're saying it's yeah, it's the Rust compiler won't let you do things because of the ownership properties of the of how it works under the hood, and they're applying the same model on the ownership stuff.
On an NFT,
And is that? Oh, sorry.
Wait, yeah.
As an NFT, and then that's wild.
And is this re-implemented, or they literally took the code from Rust and used it?
So Move is not actually inspired by Rust.
Inspired by Rust. So okay. That's
Yeah, I see. The architecture is what they borrowed.
The problem with Rust is that it's just not made for blockchain. The math is not it's not a. It's Rust is made for x86, right? There are people making Rust. I know they're not blockchain people at all, right? So you have to do a lot of things around libraries or not around the math. And you get
Well, is Sui
Really? Yeah, he's at Stellar. Oh shit. They're all Rust too.
is Rust is the best language. Let's all agree. Rust is an amazing programming language.
Wins language of the year every single year.
It has been over the last few years. Yeah.
Since its inception, I think, since 2016.
Yeah. That's it's. There's a good reason. I don't know. Yeah, I'm biased.
They associate Rust with crypto.
What?
Yeah, I'm shocked to hear that. it's hard to find. Like I was looking for Rust jobs.
Dude, Boeing uses Rust. Like,
Yeah, but it's genuinely hard to find a job outside of crypto that uses Rust.
really?
What? I mean, you can find it, but like definitely I've noticed that like if you're for like I'm definitely a Rust developer, strongest language, but like if I'm looking for a job, it's the proportion of jobs that are in crypto are like way higher than like different languages. So what I've seen in that, I don't know why we're talking about this now. You want us to wrap this back to the
No, go for it. No, this is fun.
What I've seen is that it's not that there aren't Rust jobs outside. It's that the pay disparity between Rust jobs inside of crypto and Rust jobs everywhere. Because we're desperate. Like we do a lot of Rust in my shop, and we're like, I'm constantly like seeking out Rust developers, and I'm paying them like $250, $300 a year, and like for good Rust in crypto, like whereas like, you're getting a Rust job like normally, like starting 70 kind of thing in America.
True.
And it's just like, so because of that, I think that Rust developers are saying like, I'm obviously going to go to crypto. Like this doesn't make sense because we're so starved for the talent. But yeah, that's just that's an opinion.
I went to RustConf, or it was, RustConf. I can't remember the Rust London or whatever, and it was a conference focused on Rust. So you had like Element, OnePass, like all the companies really using Rust, and we were the only like crypto people there. We had our Polkadot parody, huh?
Like Element Delve?
Element like Matrix, like Element. Element. It's just a chat. Yeah. Anyways, but this, they use Rust. They bring Rust. The sentiment in general is like it's like, ooh, why would you do blockchain? Ooh, yeah. So it's good that you say that because it means that there's going to be more of a brain drain, which we need really badly. Like in Web3, we need system programmers that know what they're doing with Rust to come to Web3. Because I think a lot of developers, they just learn Solidity, and then that's not going to cut it if you want to be doing blockchain engineering, I mean, I think the pathways would go from like, Solidity and then maybe auditing, and then you're going deeper. But do you know what I mean? Like, I would like to see more system engineers that ultimately don't care about Web3 or whatever.
System engineers are really hard to win because they need to be like already interested in these problems.
Yeah.
And otherwise, it's just like they do the safest thing. They're like super prudent people. And I don't think crypto, like building a app is not at all like system engineering. No. It's very
Not really, no.
more like application, like backend.
Yeah, it's more application stuff. But yeah, I mean, what kind of Rust devs are you hiring? You're not just hiring guys doing smart contracts, are you?
Mostly system engineers.
Yeah.
We're not like really that smart contract. Well, we are smart contract, but a lot of it's like infra tooling, like a little bit closer to, I don't know, I wouldn't say close to the metal, but like it's not really there anymore. Right. Like helping like newer networks build
Integrate.
pieces of infra, that kind of thing.
Okay, I got it.
It's really hard to find people who are competent enough in Rust to be able to start doing that stuff.
Yeah.
I'm curious on one thing. So, what about Rust doesn't have the math for blockchain?
Yeah, I was curious
So
about
you
that
said
too.
that Rust doesn't have math that's suitable for blockchain.
Oh yeah, that's interesting. What did you mean?
I don't have like maybe I could dive into the specifics, but I definitely remember I was watching
Welcome. You guys sit
Okay.
down. We're just having a chat about Rust and Web3.
I just remember from talking to the guy who wrote Move. It like something about the float specification, the way that floats are implemented in Rust, right? Because floats aren't deterministic, like architecture to architecture. So you need to have some kind of like abstraction layer and a compatibility layer, which like I guess you could do. Like I don't see like a fundamental reason why you couldn't just have Rust compile like F32 editions, like the way that gets compiled into x86, like just write an abstraction layer on that, and like I don't have like a comprehensive reason as to why you can't just use Rust.
I think you. Oh, sorry. Go ahead.
No, like at a basic level, like Rust uses. Should I grab it? Like I actually don't even remember how many bytes they use, but I think what you're saying is like the way that they wanted to store on a blockchain the like specific like float or like non-float value is like a different number of bytes than you wanted to use, but you can define like that new object as like a byte size. Like that's what we're doing in we were just recently writing in like for Fuel, like on Sway, which is like a very Rust kind of similar thing. And so like to store our like large numbers, we're using like a different, like we have to define or we're using their byte type,
But anyways, it's like
Come sit down.
you know, it's like a floating point that's defined not as the Rust floating point number, but instead as like the one that's being used on the chain.
I think that's actually, now that I think about it, I think the biggest reason is because the compiler, there's no compiler spec, so the compiler is allowed to like, you know, do things like you know, change the representation of structs. And like on blockchain, that's a huge problem. On x86, like if you're just building stuff, that's fine. But like there's so many things that are like compiler and implementation dependent that if you upgrade, like the Rust team upgrades the compiler all the time, right? And so if you upgrade the compiler in such a way that, you know, breaks things, that's fine in a way that's fine in x86. You know, now it's not fine in blockchain. You get like a fork, and it's like a, you know, big problem. So I think honestly, now that I think about it, I think that's probably the reason. It's just compiler, lack of a formal struct. Lack of a specification, and you know, upgrade of the compiler itself. Move actually does not support floating point. I wish it did. It does the same thing with like Solidity, where you have to like do, you know, integer division. But like honestly, yeah, I think it's fine.
Isn't that a good thing that it doesn't support floating points?
I would like it to support floating points. I mean, I don't. Yeah, I mean, I guess it depends. Like, just for like ease of developer use, like when you're making games and you don't care about precision, like it's nice to have like a, you know, F32 type or whatever. But
yeah, for sure. Yeah, I personally would see that more of a foot gun and a vulnerability.
yeah, when you're doing D5 for sure.
Yeah, when you're doing DeFi for sure. We've seen those errors in the early 2015 days. That's awesome. Wait, so we just drifted. We talked about like SUI and then Rust, and then have you guys code in Rust? Yeah? Oh, that's awesome. Okay. Why don't you just like tell us a little bit what you guys are up to? And like, yeah, any opinions on...
Here, take the talking stick.
Yeah, I'm actually a student, college student right now. I just took operating systems last semester. We did a couple of projects in Rust because most of it's in C, because like you basically still need C for everything. Like currently, like a lot of systems are C. But then we want to get some exposure to Rust. And it's like, it's very, very nice.
Are they teaching Rust at school? Are they telling you about it? Or they're still saying like stick to C?
Well, the thing is like C is so like hard, like coded into so many current technologies that I think like it would take a while for it eventually to phase out. But I mean, they're definitely saying like look into Rust, like this is cool. They offered us to either do it in Rust or C, like some of our projects. But Rust is great. I think it's pretty cool. Yeah. I don't know. It took me a little bit to get used to, but I think it's just very nice how like a lot of the memory is just like, I don't know, kind of done for you. Like that's like the hardest part to see. Like everyone kind of does that,
malloc
like,
and all
managing
that.
all that. Yeah, exactly. So it's very nice to like not really have to worry about that.
I mean, I think we're all biased here in the room, but yeah, Rust is a great programming language.
Yeah.
It is nice to learn with C. I think it's a good starting point because then you know the pains and then you appreciate the things that Rust could do. But huh? Yeah, probably.
Want me to repeat that, or because I was done?
What was your question?
I said, are we the only room at consensus that's all technical?
Let's hope that yeah, let's hope we don't some terrible accidents that happen, because if we all disappear, then all the other guys that are talking about the tech are fucked. Okay, so we drifted a lot here, guys, and I was showing Bagpipes. That's just like this. It's a way to construct cross-chain scenarios. So in Polkadot, right, you've got all these different application-specific blockchains, and you want to do things between them. There is a language that allows you to do that, but it's actually really hard because you need to construct all these cross-chain calls and blah, 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 blah. I demonstrated how to do it. I can share you a link after. It's really interesting. But, huh?
Get out.
Oh yeah, awesome. Yeah, tell us.
So like in seeing that, it was also really valuable. I know I talked before about wanting to own the data and all that, or own the call structure. But what was also really valuable, like it would speed up time, is just having the ability to check each of those calls. I'm not a major like Polkadot guy or anything like that, but like making those cross-chain calls is really, really like time consuming. And like you said, like, oh, I don't know if it's a swap, but it's going to tell me. Yeah. That kind of thing, super useful to even just be able to walk through, and then it would speed up our devs being able to just make the calls in one. Now that we've seen what it looks like, you know, what's been validated by Bagpipes. That was it. That was my piece of feedback that I wanted.
I
to
love
share.
it. We're gonna chat after so that I can actually capture it properly. I do like. So this is under active development. This is like cutting edge stuff that's happening in Polkadot. Guys that have really understood the pains of doing this cross-chain stuff. And what you can do basically is construct the scenario. And what I just want to show you is that they do have that as a final step, right? And so I have a scenario that says, huh? You showed us that. Yeah. But that you can see the transaction. You have that. Didn't that show up at the end of your yeah, exactly. Yeah, I just wanted to show you that one more time. This is the structure that works. And now I can pull that into my app. It's like just writing the code again. Right. Can I do USDC? See, like, it would be nice if this UI says you can't do this. Yeah. But like, can I send dot to USDC? No, I don't think. Like, no, I need. I like. It should tell me something. But if it doesn't work.
Actually, it will be nice if you want to do something that you cannot do. Suggest what you need to do or correct. Hey, yes.
Yeah.
Is this what you want to do? It's like it gives you the option directly. But
yeah,
I
so
don't
it
know,
doesn't
maybe
even give me the option here, but I know that I can bring dot. Yeah, it would be so much better. So if I, oh, it's just, is it running? Okay, select.
And also you can
select
see
action.
more or less the
I'm gonna do
idea of
cross-chain
what
transfer.
they want to build.
So here I'm
it's
just
like, okay, yes, polishing.
Hey, welcome. Join us. So it's processing the transactions, and then, oh, maybe they have something wrong with their. Hey, join. Yeah. Okay. Oh, it's just chugging along. But yeah, I showed you the gist of it. We can talk more about it. So I actually want to take this opportunity to actually have Peter demonstrate ink. Yeah. Yeah, you're feeling good about it? Okay, let's do it. That's awesome. Because there's some, a lot of us here are, I think, from different ecosystems, which is amazing. We've got SUI developers, we've got people doing stuff on Stella, doing stuff on Polkadot. And yeah, I was just going to say that diving into ink is cool. Like, what's ink? Did you guys know that Polkadot has a native smart contracting language? It's not as if it's like there's not enough smart contract languages out there already, but there's a really good reason for it. And Peter's going to talk about it. But I just want to preface it, yeah? So why is there a native smart contracting language in Polkadot? Is because with Polkadot you can have a smart contract. What's the beauty of a smart contract is that anyone can just deploy code. It's code that's being executed on chain, yeah? And well, the EVM just does really well at reading bytecode that is compiled down to EVM, right? Well, what if you had a VM that can read code and execute it and offer the same functionality, but it can also talk to the internals of other chains, not smart contracts on other chains, but like other modules in the chains, right? Polkadot has the app, like there's their application-specific blockchains, right? There's, like you guys saw, Unique Network is just doing NFTs. They have modules that are hard-coded in the chain state that just do NFTs, right? They're not smart contracts. They're deeper down. So I'm saying what Peter's going to come and present is Ink smart contract. These smart contracts that are Polkadot native because they can be deployed by anyone, but then they can also encapsulate logic that talks to chains directly. So that's really cool.